Hi everyone, it's me, Carolyn, and we are back again with some more statistics. And this video is going to talk about the beginning of chapter 3. And in chapter 3, we're going to be looking at the different measurements that we can do on data. So the different calculations that we can do on data. And our first unit kind of just looks at the middles, or the measures of center, we like to call them. So you may have heard of them. We are going to be looking at the mean, the median, and the mode. And I'll also be looking a little bit further as to how they affect our shape. Remember, if you talked about skewness, being skewed left and skewed right. So we're going to end the videos with that. But first of all, let's look at the mean, the median, and the mode. So I'm going to go to our guided notes. I also kind of want to make sure we understand. Come on, flip over for me. Here we go. The notation that we use in statistics for different things. Now, we do talk about the mean, okay? And you may have heard of the mean. It is the average. And to find it, we're going to add up all the data and divide by how many data values we have. Okay, that is a lot of words. In the mathematical world, we like to have things nice and neat, formulas if possible, and we like to use a lot of notation. Since we're in statistics, we sometimes also have to make a difference between, are we looking at our population or are we looking at just a sample? Remember, population is everything that we are dealing with. A sample is just a subgroup of that. And so we want to make the clarification as to which group we're taking the mean of. So we do have some different symbols. Statistics likes to use, when we're talking about our population, we like to use symbols that come from our Greek alphabet. So this symbol right there, which looks like a funny looking U, is actually a Greek letter. And it is the Greek letter mu. So I believe it's the M. I could be wrong. It might be the U, but it is read as mu. So all that means is this is a population mean that we're calculating. So it's just a symbol to represent population mean. So instead of writing out all these words, we write down this symbol. This next symbol that we have in there is this funny looking E thing. It does have little bars going up and down. It is another Greek letter. And it is actually the capital sigma. Okay, so it's a capital letter, and it is our sigma. We will see sigma again, the lowercase sigma. This is a lowercase mu. But this symbol basically means to add up. So we're going to be adding up a bunch of stuff, which when we're finding the mean, we add up all our data. So this little xi does represent our data. The little I that is down there is kind of just a counter. So it would kind of go through the values, however many we had. So we'd have x1, x2, x3, meaning the first data value, the second data value, and the third data value. So again, it just is a symbol to represent your data value. So this tells me I'm going to add up my data values. And then we're going to divide. And capital M is our population size. We like to make a distinction between the population and, again, the sample. So we like to use a capital N for our population size. The next sample is, example here, or formula we have, is for that sample mean. Now, sample meaning subgroup. Then you'll see this symbol here with X with a line across the top. It is read as X bar. So just the X, and that's considered a bar across the top. So this is X bar, again, just a symbol to represent the average of a sample. Again, we are going to add up all of our data points. So add up all the data. And then we're going to divide by little n, which is a sample size. Okay, so these again are just some symbols. Takes a little while to get used to them, but we will see them over and over and over again. All right, I'm going to do an example, and I'm just going to choose the first one. So I'm going to find the mean of A. I don't know if this is the whole population or a sample, so I'm not going to use one of these symbols. I'm just going to actually calculate it. So I'm going to take 3 plus 8 plus 7 plus 11 plus 5. And then I'm going to divide by 1, 2, 3, 4, 5. That's how many data values we had. So I'm adding up all of those pieces. I have 34 over 5. And 34 divided by 5 is 6.8. Okay, so this is our mean of set A. A just being the name of that group of numbers. Okay, I did want to ask a question, so that's kind of why I put this on here, some questions that I want to make sure I address. Can we take the mean of qualitative data? Well, the answer to that is no. The reason I put this on here is to remind us that there are two types of data. We do have quantitative, numerical data, which we can add those numbers together and divide. Qualitative is more descriptive in nature. And so we don't add hair colors together to try to find an average hair color. And we don't do the same with area codes or zip codes or eye color or gender or any of that kind of nature. So we don't find the mean of qualitative data. All right, we're going to move on to our median. The median, which is similar to the median of a highway, is the middle of our information. So the middle of our data. We don't necessarily have a symbol that has been used across the board that's universal. Some people will use the letter M to stand for median, but M does take on a lot of other values. So we will just find the median. We won't have a symbol for it. To do so, we actually have to find the middle of the data. So in order to do that, we have to, first of all, order our data and then actually find the middle. If we don't have a middle value, what we do is average the two values that kind of are in the middle. And I'm going to do both examples A and B here so you can see the two differences. So for set A, first thing I need to do is order my data. So I'm going to do my 3, and then I have the 5, the 7, the 8, and the 11. And I'm going to find the middle. So my middle, here's the middle value. There's 2 below it, there's 2 above it. That is my middle. So 7 is my median. Okay, set B, little different. Again, first thing I need to do is order that data for 7, 13, and 17. You'll notice we do not have a middle value. The middle is kind of right here. So what we do is we take the 2 that kind of straddle that middle, and we find its average. So my 7 plus my 13 and divide by 2. So that's 20 divided by 2, or 10. And 10 is 3 above 7 and 3 below 13. So it is in the middle between those two. So in this case, we have 10 being our median. Okay, something to kind of make sure to get into the habit of doing is just kind of looking at those calculations that we're doing and kind of seeing if they make sense. First of all, the mean and the median are kind of a way of finding a middle value of some sort. So it should be somewhere between the lowest value and our highest value. So we did set A for both of them. Our lowest value was a 3, highest value was an 11. Our 6.8 is kind of in the middle in there somewhere. Our 7 is in the middle. What's our middle value? But again, remembering when I say middle, that also kind of includes mode and mean. And if I say average, that also kind of includes median and mode. Those words are kind of simultaneously saying measures of center. So it kind of is misleading when I say find the average or find the word average out of context. Okay, we're going to do the last one, and then I'm going to go and talk about using some software to calculate these things. So the last one we have is our mode. And our mode happens to be the one that is most common. What value do we see most often? Notice we can talk about the mode when we are talking about qualitative data. We could say, what is the most common hair color? What is the most common eye color? What is the most common gender? What is the most common area code? All of those things we can talk about when we're talking about qualitative data. We can find the mode. We can also find the mode of numerical data. Just kind of put my values up here again. If you look back at our sheet, at our first couple data sets, which I threw on the floor, there they are. And if we were looking for the most common value, well, nothing's repeated. So neither one of these have a mode. So the answer to this question, can we have no mode? Yes. Both of our examples that we had before show that we have no mode. Have no mode. We could have a single mode. So let me see if I can create a set here. 3, 7, 11, 11, and 15. There. This one has a single mode. 11 appeared twice, so we would say that it is 11 would be the mode. I could change this set very quickly and put on another value. Let's say I add a 3 in there. This thing just became bimodal, 2 modes. We have the mode of 11 and we have a mode of 3. When we have more than one mode, we list them. Okay, so we don't do anything fun with them. We don't average them together. We just list them. And if there's 3 of them, we would say it's trimodal, and then we would list all 3 measures. Very easy to kind of pick off if you had done a dot plot for some of this data, because the dots would be the highest one is going to be your mode. If you have 2 bars at the exact same height, you have bimodal. 3 bars, trimodal. Someone always says, which one's better? Which is the best measurement? Well, it depends on the situation. If we're doing qualitative data, well, obviously we're going to want to use the mode because we can't find a mean or a median of qualitative data. When it comes to quantitative data or numerical data, it depends on what you want to find. If we were looking at a new job and we were trying to look at incoming salaries or starting salaries, we may not want to know the mean starting salary, because when you think about the mean, that's going to be the average. So we're going to be averaging all these possibly executive places or something. And we may want more to look at the mode salary or the median salary. What's the middle salary? What's the most common salary or most common wage? So again, they're all important in their own way. We do use the mean quite a bit more in our statistical studies, but the other 2 definitely do have their place. And one thing that they have over that mean is the fact that they are resistant. Okay, so the 2 central measures that are resistant are the mode, and I'll explain this, and the median. Both of these are resistant. So if we looked at this sample up here, I'm going to throw it down here again, but I'm going to put them in order. Okay, and if I wanted to find my middle would have been here, right? And I would have added those together. 18 would have been a 9. So there's my median. I do have two modes. I have a 3 and an 11. Now, resistant means that if I had a data value that was extremely large or extremely small, it wouldn't affect things very much. So if I had another point in this data set, let's say 257, and I'm going to put them kind of off to the side because, first of all, when we do say an extremely large or extremely small value, we first of all call them an outlier because they kind of lie outside of our data, and they do affect things. So first of all, it's not going to affect our mode at all because we only have this one. So our mode do stay the same. We still have two of them, the 3 and the 11. Our median does shift a little. Instead of being here at 9, we moved up to 11, but you'll notice the value did not change substantially. If I had calculated the average of these values, I would have gotten a number somewhere between, I should do this real quick. So I'm adding up these values, and I'm going to divide by 6. And without the 257, we have a mean, I have 8.3 repeating. If I add in that 257, and then I divide by my 7, my new mean, so with the 257, the mean becomes a 43.9. So that is a substantial change. In fact, that mean is now above where most of the data lies. So kind of remembering, so that tells us that the mean is not resistant to large values. It does get affected by these large values or small values. All right, I do want to go now to looking at our software that we have to help us do some of this. Because if we had a data set that was, let's say, 1,000 pieces of information, that's a lot. We would not want to have to add all 1,000 values together and then divide by that 1,000. My fingers would get tired of pushing all the buttons, and I'd probably forget one or two, or I'd mix up the numbers, or something would happen. Okay, so that's where statistical packages come in to play and can help us out. So what I've done is I just, first of all, put in the set that we were working with. This is set A, and then I just randomly picked another set. I'm in StatCrunch right now, so you should be able to see our StatCrunch, and I kind of want to show you how we can get the mean, median, mode, and so forth. So first of all, I'm just going to go into stats. So all of this information is under our stat category. And we're going to do a summary stats. This is where we can find a lot of information. We'll get more than we need today, but I'm going to go into summary stats. Since I put our data in columns, I'm going to go to columns. Okay. And for this first time, I'm going to just do it on variable 1. So here's variable 1. And I'm just going to go with the default. So I'm not going to change anything else. So we can kind of see what you get just going with the default. Okay, so here's my summary statistics for variable 1. The column is variable 1. We had n, our sample size is 5. It does not know if it is a sample or population, so it errs on thinking it's a sample, simply because we do more calculations on samples than we do on populations. So here is my number that we have. We had 5. We did get a mean of 6.8. That was something we calculated before. These pieces of information we'll come back to. We'll see this in 3.2. There is our median. Again, we'll do some of these other ones later in this chapter. You'll notice mode is not listed here. Okay, to find the mode, I'm going to do it one more time. We'll go to summary statistics, columns. If you scroll down, you have to scroll down a little bit. So notice that these are all highlighted. There are a bunch of other ones. I'm going to click on the mode. You'll notice everything else disappeared. Mode is right there. And then I can calculate my mode. And oops, I forgot to put volume 1, variable 1. There we go. And it tells me that there is no mode. So there you are. And I could have seen that looking at just 5 single values. We only had a couple. Okay, I'm going to do the same thing for variable 2. I'm not going to go through and find the mean, the median. I'm just going to look at the mode because I see that there are some repetitions in here. And instead of trying to organize it all and do all that, I'm just going to let my software help me out. So we're going to do this one more time. We're going to go into stats, summary stats, in columns. This time I'm going to pick variable 3, and I don't want any of this other stuff. I simply want the mode. So I'm going to go and find my mode, and I'm going to hit calculations, and notice it tells me it has multiple modes. Well, that didn't tell me a whole lot of information. So I would have to go and actually find those multiple modes. And this is where I'm going to switch over now to Excel, because Excel does a little bit better job finding our mode when there's more of them than StatCrunch does. Every software, statistical software, has weaknesses and strengths. StatCrunch does a wonderful job a little bit later on some of the calculations we're going to be doing later in this course. When it comes to the basics, I still prefer Excel. That's just me, but that's just how I'm more comfortable with Excel than I am with StatCrunch. I'm still learning both, actually. But we're going to move now, and I'm going to go into Excel just so we can see it. And I did type in the exact same second set. And I'm going to kind of show you how to find all of them. So the mean and the median, and we'll try to find the mode as well. Okay, so this is a little bit different than it is for StatCrunch. We're going to be using this little FX button. This tells us we're going to insert a function. Excel has I don't even know how many functions it does have, but there are a number of functions that it can do for you and so forth. So I'm going to just hit this little FX button, and it's going to pull up a screen, pop up a screen. The ones that you most often use will be listed here. And I have quite a few of them that I use quite often, or that I have used often in the past. But I'm going to go to where I usually go when I'm doing a statistical class. So I'm going into this drop-down menu on the category, and I'm going to go to statistical, because it makes sense that if I'm doing a statistics class, I'm going to do some statistical formulas. And unfortunately, they don't use the word mean. They do use the word average. And we do have that listed right at the top. These are alphabetical in nature. So I'm going to click on average. It does give me a little description what it's calculating. So it's giving me the average arithmetic mean of all the arguments and so forth and so on. So I'm going to click OK. Now what it's asking here is, where are those numbers found? I usually go back to the data and click and drag those values. So A1 through A10. And then it does kind of spit that number out. So there's my 15.9 is my mean. So you can see it on the pop-up menu, and you'll also see that once I hit OK, it puts that into that cell. All right, so I can do this again here. I'm going to go down to this one, and we're going to now do the median. And I do have to find median. These are alphabetical, so I'm just kind of scrolling down, and there's my median. I'm going to click OK, so it's finding the median, the middle. And here again, I need to grab my data. You can type this in. So if you wanted to type A1 colon A10, you can do so. So again, it's listing those numbers there for you. It is finding the middle, which is 13. And now I'm going to do one last find the mode. And we'll scroll down. And we will have some options for our mode. If we know that there's more than one, or if there's a single mode we can pick. If you don't know and you want them all, I usually just pick the mode.multi and find all of them. Again, I need my data. You'll notice that it does find both of my modes. So here we did have multiple modes, as StatCrunch told us, but here it actually lists them for us. And I'm going to click OK. And you'll notice it does list them vertically. So 12 and the 13 were our two modes. So again, when it comes to finding multiple modes, StatCrunch will tell you that there are some. Excel will actually find them. All right, we have one last thing to talk about, and I'm going to go back to my guided notes and finish off this material on our centers. So we're going to look at the shape. Okay, so we may remember from chapter 2, we started talking about symmetry, being symmetric, normal, bell-shaped curve, or if things were skewed left or skewed right. So if we're looking at this nice normal bell shape, I'm just going to kind of draw some bars that kind of look bell-shaped-ish. Okay, and if we were trying to find our mean and our median and our mode for these things, well, I'm going to start with the easier ones. Our mode is the most common, since this is the highest bar. This is where our mode is. Our median is the middle, since it is nice and symmetric. It is also here. Our mean, which is going to be the average of these two. These guys would kind of average together to give you that middle. It would also be in that middle. So if we have a normal bell-shaped curve, the mean, the median, and the mode will all fall really close to each other. Okay, so let's think about something that is skewed left. Now, remembering skewed left means it had a tail to the left. So we had some pieces down here, but for whatever reason, the bulk of our stuff was up here. So we had a few things that kind of tailed off to that left. All right, so if I'm going to find the mode, again, that's my highest value. My mode is right here. My median, which is the middle. Now we do have some guys down here, so our median is going to be probably over here somewhere, exactly where I would need the actual data. So it might slide a little bit that direction. But the median, remembering that one is the mean, sorry. The average, and Carolyn. The average, sorry about that, I should have said mean. All three of those are in the middle there. The average is going to be greatly affected by these small values. Remember, it's going to kind of pull them that direction. So I'm going to just put the mean here. How far down it gets pulled is really hard to say depending on the data. But the reason it said skewed left is because the mean has been skewed to the left. It has been pulled to the left. Similarly, for skewed right, I can flip this graph a little bit. We had a couple people up here. Okay, this is going to be our mode. Our middle value is probably in here somewhere. But these really large values are going to skew that mean to the right. So when we talk about skewness, we're talking about where did that mean get shifted to? It got shifted to the right of all of these guys. It got shifted to the left from the other pieces. If the things are nice and bell-shaped, they're all pretty much right smack dab in that center area. So that's kind of where that left and right idea came from. that we had before. Before we said just kind of look at where that tail was. Now we kind of want to say, okay, where did the mean go? Did it go to the left? Did it go to the right? If we calculate the mean, the median, and the mode, and we see that they're all about the same value, then we have something that's somewhat symmetric, something all kind of grouped in that middle. If the mean is all of a sudden a lot larger or a lot smaller, then it's going to be skewed one way or the other. Hopefully that helped a little bit bring back some friends, your mean, median, and modes, and also talked about how those skewness got their names. So I will see you in our next video.